Everything you need to know about drawing chair conformations and performing ring flips. Keep watching. Let's say the question asks, draw the chair conformation for the following structure, presented here. Step 1 is label all the carbons on your structure. The labeling is arbitrary. I just always prefer to start my labeling of number 1 at the top of the cyclohexane. Step 2 is to draw your right-handed chair to start. I'll do a whole nother video on how to draw a chair. But for this video, let's assume we know how to draw a right-handed chair. On the right-handed chair, I want you to label carbons number 1 to 6 in the same rotation as you did on your original structure. Hence, clockwise label the carbons 1 all the way to 6. Now, the reason we label is because we are saying carbon 1 on my structure is equal to carbon 1 on my chair, so on and so forth for all the other numbers. Now, to draw in the axial and equatorial bonds, I want you to start at carbon number 1. The first thing I want you to do is on the vertical line, so between carbons 1 and 2 and carbons 4 and 5 on our chair, I want you to extend that line slightly from the top to the bottom. This will be both your axial up and axial down bonds on both sides of the chair. Easy as that. I've drawn them in pink. For the equatorial bonds, it's a little more complicated. On the horizontal-ish lines of the chair, I want you to extend out each of those horizontal lines. And you are pretending you are extending those lines to infinity and beyond. Now, all you need to do to draw on the equatorial bonds is at each carbon, you need to draw your equatorial bond in the opposite direction as the line going to infinity. Here I have drawn them in orange. So we can see all the orange equatorial bonds are drawn in the opposite direction of the line extending away from that specific carbon. That's it, that's all. Then finally, for carbons 3 and 6 in this structure, you just need to draw in an axial and equatorial bond on both of them. Now that we've drawn in all our axial and equatorial bonds on our chair structure, all that's left to do is put in the substituents that were on our original structure on the chair. Starting at carbon number 1 on our structure, we see that bromine is on a wedge. Wedges equal up bonds. I also want you to draw in the hydrogen on the opposite bond. Hence here, the bromine is on a wedge, so the hydrogen needs to be on a dash on both carbons 1 and 4. Now on carbon 1, to figure out which bond is the up bond, I want you to extend both of the bonds to infinity and beyond with a dotted line. Then, assuming up is the sky, down is the ground, you ask which line will reach the sky. That is the up bond. Hence, the one pointing up towards the sky is the axial up bond. That is where the bromine goes. Hydrogen is on the line that goes towards the ground, hence the down equatorial bond. For carbon 4, we do the exact same thing. We see on our structure, bromine is on a wedge, hydrogen is on a dash. Bromine, the wedge is the up bond. Which bond is the up bond on our chair? I want you to do the exact same thing. Take each of the bonds and extend them from carbon 4 on the chair with a dotted line. Then you ask, to infinity and beyond, which line will go and approach the sky? That is the up bond. Hence, the equatorial bond here is the up bond, which is where you put the bromine since it was on a wedge. And then the hydrogen on carbon number 4 in our structure goes on the down axial bond, which approaches the ground, hence down. 1, draw out your right-handed chair, and below it or to the side, I want you to draw out your left-handed chair. I want you to label your right-handed chair in the exact same way as we labeled it in the first part of this question. We labeled it 1 to 6 in the clockwise direction. So now all you have to do to label the left-handed chair is rotate each of the labels on your original right-handed structure over clockwise 1 carbon bond. So number 1 will move down 1. Number 2 will move over 1. Number 3, over 1. 4, over 1. So on and so forth in the clockwise direction, which I have shown here. Now on the right-handed chair, draw in the substituents on carbons 1 and 4 that we established. Now listen carefully to what I'm about to say. Proceeding a ring flip, up stays up, down stays down. Axial turns to equatorial, equatorial turns to axial. Hence, on carbon 1, our bromine is in the up position on the axial bond. Hence, on the left-handed chair, it will be in the up equatorial bond. It stayed in the up position, but it changed from axial to equatorial. The bromine on carbon number 4 was initially in the up equatorial, hence on the left-handed chair on carbon number 4, bromine will be in the up axial position, and vice versa for the hydrogens. That's it, that's all. Finally, to finish it off, just draw in all your hydrogens on all the other carbons on the chair, and then you're done. From here, we can do separate questions saying, let's evaluate the stability of this chair conformation, which one is more stable, but that's for another video. Hopefully this helped.